I want to introduce a new concept and do a couple more examples that are a lot simpler. So I want to discuss heat capacity rates. So when we have this equation, right, to calculate the duty of the heat exchanger, this is delta T of the hot fluid, right, which is and this is called the heat capacity rate, that is a big CH. So in the board it's so difficult to make the C, right? And we would have a similar one for cold. Now, what's the point of this definition? Actually, there is a point, and it's an important point. And it is this, that if you have, now I write this equation as delta TH as Q over, and I would write the same for cold. What it says is that if I have a bigger heat capacity rate, right? Heat capacity is like thermal inertia, right? And the delta T is like motion. So if I have a big heat capacity rate, if I have a big inertia, the temperature is going to change little. And how do I get this big inertia? Well, I can have either fluids that have a very high heat capacity, or I can have a lot of flow. And the reason this matters is because it enhances your intuition, because changing flow is as easy as turning a knob, right? Like a cookie, you go on the valve, you increase the flow, and you throw your whole heat exchanger either out of balance, or is what you save with your knowledge. Tell me, how can I have a very heat capacity rate? How can a fluid have a really high specific heat? For example, water. Water can have very high specific heat. When and how? How about water at 0 Celsius? Okay. If you remember, specific heat is delta enthalpy over delta temperature. At 0 degrees or 100 degrees, if we're at atmospheric pressure, the delta enthalpy is the latent heat, but the delta temperature is 0. So the heat capacity at a phase change point is infinite. So if I'm having a condenser or a boiler, this is essentially infinite. And this is 0. So, what would this heat exchanger look like? I'm going to write, what would a heat exchanger look like if I'm condensing? What would this heat exchanger would look like if I'm condensing? If I'm condensing, the fluid that is condensing is gaining heat or losing heat? Losing heat. If I'm condensing, I'm losing heat. If I'm losing heat, who am I? The hot fluid or the cold fluid? Hot fluid. And if I am condensing and I'm the hot, I'm going to use this. How much does my temperature change? It shouldn't, right? Like let's say it's all condensing. Of course, you can have like beginning and end that are a little bit different. How about the cold fluid? Let's say it's a counterflow heat exchanger. If it is counterflow, it's flowing like this, right? Then it's getting hotter, right? Right? It would be something like this. Now, if now it's a parallel flow, is that right or is it wrong? It's right. If now it's a counterflow, is it right or is it wrong? Isn't that interesting, huh? What is it? Cold fluid, getting colder. Yeah, we'll get brain cramps, right? But to some extent, this is no. Or you got a Nobel Prize, right? So I think time's up. We're going to stop here and have a good weekend. Monday, Tuesday, we're going to go about radiation.